Alright, in this video, I'm going to talk to you guys about using a hand trick to find the sine, cosine, tangent of special angles. Now, we've already learned how to do this using right triangles and how to do this using the unit circle. So this is just like a quick way, if you can remember the trick, to find the sine, cosine, and tangent of these special angles. So it talks about on this paper to use your non-dominant hand. My non-dominant hand is my left hand, but I think the left hand also works better because it looks like where zero actually is. So the horizontal pointing to the right is the angle that's zero, and then the vertical is the angle that's pi over 2 or 90 degrees. So you can use your left hand or your right hand, but when I do this, I'm always going to use my left hand. So what you do is you assign angles to your hands, and these angles, in this case, are in radians. You can use degrees, that's perfectly fine. When I talk about this, though, I am going to be talking about radians. Alright, so the angles that you assign, your pinky, if you're using your left hand, well, both hands actually, your pinky is going to be 0, your ring finger is going to be pi over 6, your middle finger is pi over 4, your pointer finger is pi over 3, and your thumb is going to be pi over 2. Alright, so then if we want to do a trig problem, for example, if we want to do cosine of pi over 6, you find your pi over 6 finger, which in this case is your ring finger, and you hold it down for that assigned angle. Alright, so I'm going to zoom out just a second. So you would hold down your pi over 6 fingers. This is what you're talking about. And then for cosine, it is the square root of the top fingers over 2. So when you hold down the pi over 6 finger, there's 3 top fingers. So the cosine of pi over 6 is the square root of 3 over 2. Which is what we talk about in this bottom step. Alright, if anytime you want to find the sine of one of these special angles, you do the same thing at the beginning. So you do the same thing at the beginning, you find which finger is the sine to that angle, but for sine, it's the square root of the bottom fingers over 2. And then finally, for the tangent, it's the square root of the bottom fingers over the square root of the top fingers. Alright, so we're going to do a couple of these. So if you have a piece of paper or if you printed out the hand trick sheet, then you can do this on the back. Alright, and so I have a little cutout of the hand, so as I go I don't have to flip around different pages, so you can draw a hand and label your fingers, or you can print off 2 pages and do a cutout if you want to. But we're going to call this the Trig Handtrick. And we're just going to do several examples. So the first ones I'm going to do are going to be these angles, these actual angles. And then I'm going to do some that are outside of quadrant 1. And so these fingers are associated with angles that are also outside of quadrant 1, but we do have to think about negatives once we get outside of quadrant 1. Alright, so for our directions are just to evaluate. Alright, so the first one we're going to evaluate is going to be the sine of pi over 3. So we'll take our pi over 3 finger, which is the pointer finger, and you're going to bend that one down. So take your pointer finger, pin that one down, and then anytime we're doing the sine using the hand trick, it's the square root of the bottom fingers over 2. So when we use pi over 3, there's 3 bottom fingers, so that's going to be the square root of 3 over 2. And that's it. Alright, for the second one, we're going to find the cosine of pi over 4. Alright, anytime we're doing the hand trick with pi over 4, it's the middle finger. And then the cosine is the square root of the top fingers over 2. So that's going to be the square root of 2 over 2. Alright, so let's do a tangent. Number 3 is going to be the tangent of pi over 3. Now tangent's different. On tangent, we do the square root of the bottom fingers over the square root of the top fingers. We still use these fingers. So pi over 3 is the pointer finger. So we're going to do the square root of the bottom, so the square root of 3, over the square root of the top, which is square root of 1. Alright, and then we all know the square root of 1 is 1. So that's just going to simplify to the square root of 3. Alright, let's look at number 4. Number 4, we're going to do the cosine of 0. So 0 radians is the pinky. So we bend down the pinky. And then for cosine, if you guys remember, it's the square root of the top fingers over 2. So we have 4 top fingers, so the square root of 4 over 2. The square root of 4 is 2. So when we do 2 over 2, it's just going to be 1. And then for number 5, we're going to do the tangent of this pi over 2. Alright, pi over 2 is the thumb. And whenever we do tangent, it's the square root of the bottom over the square root of the top. So I know my numerator is the square root of 4. But I don't have any fingers above my thumb, so the denominator is going to be the square root of 0. Right? And the square root of 0 is 0, so we basically have 2 over 0. And we all know we cannot divide by 0, so the tangent of pi over 2 is undefined. Alright, now we're going to do 3 that are outside of quadrant 1. And like I said at the beginning, when we get outside of quadrant 1, we do have to think about positives and negatives. Alright, so number 6, we're going to find the cosine of 5 pi over 6. So really, I think the most difficult part of doing this is deciding what quadrant 5 pi over 6 is in. And the way the angles work, the special angles that have 6 in the denominator, in quadrant 1, that's 1 pi over 6. In quadrant 2, it's 5 pi over 6. In quadrant 3, it's 7 pi over 6. And then, I didn't draw that very accurately, but it's 7 pi over 6. And then in quadrant 4 is 11 pi over 6. So each one of those are just 1/6 of pi away from the x-axis. So if I went 1 more 6, I would get 2 pi here. If I went 1 more 6 of pi, I would get pi. And then this is pi plus another 6. So that is how they work. So that might kind of help you determine which quadrant you're in. So 5 pi over 6 is 1/6 of the way before you get to pi. And so that is quadrant 2. And then we all know the acronym, all students take calculus. So in quadrant 2, the cosine is going to be negative. So we just put a negative there, and then we're good. We don't really have to do anything different than what we did on the first 5 after you get that negative determined. Okay, so if there is a 6 in the denominator, it's in reduced form, there's a 6 in the denominator, we use the pi over 6 finger. So what we'll do is just go ahead, I notice there's a 6 in the denominator, I use the pi over 6 finger. And then if I'm doing the cosine, I'm going to do the square root of the top over 2. So square root of 3 over 2. Alright, and then for number 7, we're going to find the sine of 7 pi over 4. Alright, and then I'll talk about how the pi over 4s work in the quadrants. So 1 pi over 4 is definitely in quadrant 1. And then what we do is just go to the next odd number. So in quadrant 2 is 3 pi over 4. In quadrant 3 is 5 pi over 4. And then in quadrant 4 is going to be 7 pi over 4. So we're just going to the next odd number and then pi over 4. So 7 pi over 4 is quadrant 4. Okay, and then we have to think about, is sine positive or negative in quadrant 4? So according to all students take calculus, the only one of the original 3 positive in quadrant 4 is cosine. So sine is negative. Right? And then because it's in reduced form and there's a 4 in the denominator, I just use the pi over 4 finger. And when I find the sine with the hand trick, it's the square root of the bottom over 2. Alright, and the last one I'm going to do today is the tangent of 4 pi over 3. So I want you guys just to take a second and see if you can write how the pi over 3 angles go in the quadrants. So obviously, pi over 3 is in quadrant 1 because it's one of our angles in our hand. All those in the hand are either on the x-axis, y-axis, or in quadrant 1. So that's pi over 3. 2 pi over 3 is going to go in quadrant 2. 3 pi over 3 is actually pi. Right? And then 4 pi over 3 is in quadrant 3. 5 pi over 3 is in quadrant 4, and then when we get to 6 pi over 3, that's going to be 2 pi. Alright, so 4 pi over 3 is in quadrant 3. Okay, so think about if tangent is positive or negative in quadrant 3. So tangent's definitely positive in quadrant 3, so we're going to have a positive answer, so we're done thinking about that. We can just go to the hand trick. Since 3 is in the denominator, we use our pi over 3 finger. And then tangent is the square root of the bottom fingers over the square root of the top. So that's the square root of 3 over the square root of 1, which just simplifies to the square root of 3. Alright, so that is the hand trick. Now, I cannot take credit for inventing the hand trick. I found it somewhere on the internet. I don't see anything on my paper that gives credit to anyone, but I do love it, and I love teaching my pre-calculus students it after they've learned other ways to do it.